Hello there again. I'm here to present to you the first carboxylic acid derivative, which is esters. In this particular part of presentation, I will include a mere introduction of esters and a few information about its chemical and physical properties.
Hi! Before we take on a full discussion about this specific carboxylic acid derivative, which is ester, let me first take a quick review of the structural formula of carboxylic acid. So in this general formula of carboxylic acid, we may observe that there is a functional group which is stated by an R, which is connected to a carbon, in which that carbon is connected to a double bonded oxygen and is also connected to a single bonded oxygen and hydrogen. But what happens when we take OH out of that carboxyl group? That's where we will create the what's so-called derivatives. So let me just write that up. So that would be R connected to C, double bonded with an oxygen, and some of the resources usually use Y to indicate the new functional group that pertains to the ones that have replaced OH. And now let's move on to esters as a derivative of carboxylic acid. So what happens to esters is that OH is replaced, specifically H, is replaced by another functional group. So let me just write its structural formula. A functional group connected to a carbon, in which that carbon is connected to an oxygen, and that same carbon is connected to an oxygen and another functional group. So now let's move on to naming them. So in naming esters, the first thing that we must remember is that esters are a formula in which a carbon is connected to a double bonded oxygen and single bondedly attached to another oxygen, and which that oxygen is connected to another functional group of carbons. So in this case, we must remember to first place the number 1 as a numbering of carbons to the carbon on which the double bonded oxygen is connected. So in this case, I would place number 1 here. So let's count that. That would be 1, 2, 3, 4. So in this case, we have 4 carbon atoms, which pertains to bute. And take account that there is only single bond present in this particular parent chain, so we will name that butane. And since there is a presence of esters in this particular structural formula, we name that as butanoate. So the question is, how about this hanging group? How about this hanging substituent group? So we name that as we name other groups that are connected to a parent chain. So in this case, there are 2 carbon atoms. So that would be eth. And since it is hanging, we name that as ethyl. So now we have ethyl butanoate. Now let's move on to the second example. Let's do the same procedure. Put number 1 on the carbon on which the oxygen is double bondedly attached to that carbon. So that would be 1, 2, 3, 4, 5, 6, 7, 8. So we have octanoate. This is also because there is no presence of double bonds in the parent chain. So we name that as octanoate, which pertains to having 8 carbon atoms and presence of single bond. Now, we name this one. We count the carbon atoms again for the substituent group that are attached to the oxygen. So that would be 1, 2, 3, 4, 5. And that would be named as pentyl since it is hanging. Now we have pentyl octanoate. And now let's move on to a more complex example of esters, which is presented to you in this example. So how about this one? So let us first start numbering this carbon atom. So 1, 2, 3, 4, 5, 6, 7. If we remember them, most of them are named alphabetically. So in this case, we have a parent chain of heptanoate because of the presence of single bonds on this specific example. Then we could see that there is a presence of bromo and an oxo group here. At 6, we have 6-oxo. Then we write bromo, 4-bromo. And since there is a hanging group, methyl, and we take into account and we give more importance to the alkane group, to the family group, we name that as methyl 4-bromo 6-oxo heptanoate. So why do we need esters? And what are the reactions and how to create esters? So how are esters produced? So when a carboxylic acid reactant is reacted with an alcohol using an acid catalyst, then esters plus water is produced. So let me give you a specific example. So in this particular example, we see that an ethyl alcohol, an alcohol reactant, is added to an acetic acid, which is an example of carboxylic acid. Then it goes to a process known as esterification, in which it will create ethyl acetate, an example of esters, and water. So on this acid, one of the examples that is used as an acid catalyst in esterification is sulfuric acid, or H2SO4. So I have written here the general formula for this specific reaction, which is a functional group which is connected to an oxygen and a hydrogen, an alcohol, plus an H and an oxygen connected to a carbon, which is double bonded with an oxygen. This would create which is known as the carboxyl group, and is also connected to a functional carbon group, creates a product of an ester. So as you have seen here earlier, I have already boxed this particular part of this formula, since this part, H plus HO, creates water. And what happens is that when this HO is replaced by this RO, that's the time where it will create esters. Summarizing it all, once this OH of carboxylic acid is fully replaced and a new set of oxygen and functional group is added to this specific compound, that's the time we call it ester. So let's move on to the properties of esters. So esters has a pleasant fruity odors. Ethyl acetate, for example, smells like apple, while ethyl butanoate smells like peaches and apricots, while octyl acetate smells like orange. They are commonly used as nail polish removers because of their polar and nonpolar groups, which makes them an excellent solvent. They also have a lower boiling point than acids or alcohols. So another information about esters is that esters are called alkyl carboxylate. Let's move back to the reactions. So alkyl came from the alcohol reactant, which is called alkyl alcohol. So this part of the reaction is what makes it alkyl, and for carboxylate refers to the carboxylic reactant that is added to that specific reaction. So that would be it. That would sum up my presentation, and thank you for listening.